So these are the symbols for the positive edge and for the negative edge triggered D flip-flop. So I need everybody to be very attentive, and this is the JK flip-flop. Please, whatever you are doing, if you're sleeping, if you are not attentive, please wake up, and you should be focusing on this slide and whatever I'm saying. Okay, we have this D flip-flop, this positive edge triggered D flip-flop over here. How do I know this is positive edge triggered? Because there's no NOT gate at the symbol of this gate over here. So this tells me that we have a positive edge triggered D flip-flop over here. What does a positive edge triggered D flip-flop do? It just waits for the positive edge of the clock for D input to pass on to Q output. So what does a JK flip-flop do? Let's start with some basic states. If J is equal to 0 and K is equal to 0, can anybody tell me that if one of the inputs of a AND gate become equal to 0, yes, the output definitely becomes equal to 0. Had it been a NAND gate, what would have been the output? If it was
1.
a NAND gate, yes.
1, sir.
1. Very good. Okay, so we have a 1 over here. What happens at the output of this AND gate?
1.
No.
Sir, depend.
Depend, and it depends on
Clock, I guess.
Q, sir.
Q, because this is the Q that is being passed on to this input, and whatever the Q is, if Q is 0, the output would be equal to 0. If Q is 1, the output would be equal to 1.
1.
1.
What would be the output of this OR gate? Am I right?
Yes, sir.
Since we have a 0 coming from this side, and if Q is 0, the output would be 0. If Q is 1, the output would be 1. So the decision
Yes, sir.
is dependent on this OR gate. So the output of this OR gate would become equal to Q. Any confusion still now?
No, sir. मतलब Q
No,
bar
sir.
का कोई role नहीं है.
No. In this state, in the 0, 0 state, we do not have any role of the Q bar. If output was Q and D is being fed with input Q again, are we going to have any change at the output states?
No.
No. So this means that for a 0, 0 at the J and at the K, the output is no change. Is this okay?
Yes, sir.
Is everybody clear with this?
Yes, sir.
Okay. So for J and K, the J and K flip-flop, for J and K both equal to 0, we have the no change state, or we also call it the memory state. There will be no change at the outputs. There would be no change in the Q and Q bar if we have 0, 0 as inputs to the JK flip-flop over here. I would erase all the ink on the slide and move to the next state, which would be 0 and 1. Okay, if this J is equal to 0, the output of this AND gate is definitely going to be equal to
0.
0. Good. What happens to the output of this AND gate?
0.
This OR gate?
0.
Change आ जाएगा.
Very good. But what happens if D is equal to 0? the Q is definitely going to be equal to 0 whenever we have a positive edge of the clock, right? So this means that for J and K, 0, 0,
0, 1.
no change. And for 0, 1, we have the reset state. Am I right?
Yes, sir.
Okay, just bear with my writing. Q would become equal to 0 and Q bar would become equal to 1 if J is equal to 0 and K is equal to 1.
Sir, ये Q bar 1 कैसे एक
Because Q bar is just going to be equal to opposite if we remember the D flip-flop from this slide.
Yes.
Okay. The next stage is J is equal to 1 and K is equal to 0. Okay, so this one is interesting. If K is 0, we'll have a 1 over here. Am I right?
Yes.
This means that the output of this AND gate would become dependent on Q, and the output of this AND gate would become dependent on Q bar.
Q bar.
So we'll have Q bar at the output of this AND gate, and we'll have a Q at the output of this AND gate. Can anybody tell me what is going to be the output of this
Q
OR
I
gate?
get.
I'm writing down.
Q plus Q bar.
I'm writing down a hint over here that we had studied before mids in the very start of this course. What is the answer of this equation?
Q आएगा
No,
sir.
sir.
X plus X bar is equal to?
1.
Yes, who said?
1.
So 1.
Very good. We have this always equal to 1. Rafe, is there an issue with your mic? Because you're always replying on the text. Or Rafe is sleeping. Okay.
सर उसके पास mic नहीं है.
Okay. So the output of this OR gate is definitely going to be equal to 1. Okay, Rafe, I've read your text. So what happens at the output Q and Q bar now? The Q would definitely become equal to 1 and Q bar would become equal to 0 whenever we have a positive edge of the clock. So this means that J equal to 1 and K equal to 0, we have the set state. Any questions till now?
No sir.
Is this clear to everybody?
Yes sir.
Okay. Now we have the last of the combinations left for this one. We have 1, 1 over here. If we have the 1, 1 input, this becomes 0. And the output of this AND gate becomes equal to
0.
Very good. What happens to the output of the above AND gate?
Sir, it is dependent.
Q depend करेगा. जी.
On Q bar, right?
Yes sir.
So the output of this AND gate becomes equal to,
Q bar.
yes. What happens to the output of
Q
this
bar.
OR gate?
It is dependent on, it would be also that of Q bar.
Yes. Can now anybody tell me that if D is being fed with Q bar, what would happen to the output of this circuit?
चेंज आ जाएगा सर Q 0 होगा तो 1 हो जाएगा 1 होगा तो 0.
Very good. So can I say that the output would become complemented, toggled, whenever J and K are equal to 1, 1?
Yes sir.
Yes.
So whenever J is equal to 1 and K is also equal to 1, the output of this circuit that's in front of us would get complemented. This means that if Q and Q bar were equal to 1, 0, they would become equal to 0, 1. And if they were previously equal to 0, 1, they would get equal to 1, 0. Any confusion, any question till now? Yes.
No sir.
Okay, sir. Josefa, Mehroz, Bilal, Ansab, Saud, Muawiz, Arham, Isha, Mehreen, Somia, Abdullah Hassan, Haram, Zohaib. Are you guys sleepy? Is this understandable to all of you?
Yes, sir. Yes.
Yes, sir.
No questions? Clear?
No, sir.
Okay. So this JK flip-flop that's in front of us is represented with the symbol that is presented on the right side over here. This JK flip-flop has the truth table that's in front of you now. If J and K both are equal to 0, the output has no change. If J is equal to 0 and K is equal to 1, the output is resetted. If J is equal to 1 and K is fed with a 0, the output becomes set because Q becomes equal to 1 and Q bar becomes equal to 0. Similarly, if both of the J and K are equal to 1,
Alternate output.
yes, we'll have a complement at the output. That is, if it was 1, 0, we'll get a 0, 1, and or if it was 0, 1, we'll get a 1, 0.
Sir, excuse me sir.
Yes.
सर ये लाइक क्वेश्चंस में जो आएगा वो आप यही पूछेंगे कि जे के फ्लिप फ्लॉप बनाना है पूरा उसका सर्किट?
No, there would be some scenario where you would be needing JFK flip-flops or the D flip-flops or the positive edge triggered flip-flops. I can also give you making a circuit like that, but that would be too basic of a question to be asked from you guys. So we are going to use just these symbols, and we are going to make circuits from them, the sequential circuits. We are just learning about the building blocks of those circuits.
मतलब सर इनके बस आउटपुट्स वगैरह याद रखने हैं?
Yes. You should remember that what does a JK flip-flop do? First of all, we had a look at the positive edge trigger D flip-flop, which told us that the output of the D flip-flop, positive edge trigger D flip-flop, changes only when we have a positive edge at the clock. And whatever is at the input D passes out to the output Q. If it's 0, it would be 0. If it's 1, it would be 1. Only when we have the positive edge of the clock. Similarly, the opposite happens at the negative edge triggered flip-flop, where only a 0 at the clock, a 1 to 0, will transfer the D to the output. If it's 0, the output would be 0. If it's 1, the output would be 1. Then from this D flip-flop, the D flip-flop looked like this, which was made from itself, which was made from a S-R latch. Then from this D flip-flop, we have been able to make a JK flip-flop. What does this JK flip-flop do? This JK flip-flop has 4 states where J and K are equal to 0, 0, and they get a memory, where J and K are equal to 1, 1, and we get a complement. If you see, this is quite similar to the S-R latch thing that we had discussed already earlier in our previous classes. where we had memory state, where we had the complement state or things like that. But the difference in this SR latch and the flip-flop, what do you see? What's the major difference in the flip-flop and the latch?
Yes sir, दोबारा क्वेश्चन एक बार करें कि SR लैच में और फ्लिप फ्लॉप में क्या डिफरेंस है?
Yes. What's the major difference that present between these SR latches? We have combinations of the memory state and the input state and the toggle state over here as well. But what's the difference between SR latch and the major difference between the SR latch and this flip-flop?
A number of gates sir, I guess.
Okay, Rafi has replied.
सर क्लॉक का क्या है?
Yes.
सर complement state तो नहीं?
We have this thing over here which is called the clock. The output is not only being controlled by the J and the K, but also by the clock. If we do not have a positive edge of the clock, whatever you make the changes at the J and K, they are not going to be transferred at the Q and the Q bar until and unless you have the positive edge of the clock over here. So you have kind of a control switch that's passing the inputs to the outputs until and unless the conditions are met. Is this clear?
Yes, sir.
In the SR latch, the things were only dependent on the input S and the input R. But in the D flip-flop, J-based JK flip-flop, the output is also dependent on this clock. Is this clear? Any questions?
No, sir.
Okay. So we have a T flip-flop now. It's also called a toggle flip-flop. Looking at the diagram that's in front of you at this left side, what do you see what has been done over here? The J and the K have been shorted to a single input called DT.
Yes sir.
This means that you can never have a state where J is equal to 0 and K is equal to
1.
or the J is equal to 1 or the K is equal to 0.
0.
You can
दोनों की
never,
सेम इनपुट्स जाएंगी ना?
yes, you can never have these states. So this means when you can never have these states, you can never have the set and the reset capability. You cannot set reset the JK flip-flop.
Yes sir. Sir, either there will be no change या तो complement होगा.
Very good, very good. So we have only one of the options available, that either T is 0. If the T is 0, the output Q and the Q bar, they will retain
Not
themselves.
change.
They
Yes.
will not change. And if the toggle switch is 1, Q would become equal to Q bar.
Q bar and Q
would
bar
be
will be
equal
Q.
to Q.
Q.
So this means that by shorting the two inputs of the JK flip-flop, we have just limited ourselves to two inputs, which is J and K equal to 0, 0, or J and K equal to 1, 1. This is being done with the help of a single input switch, which is toggle switch. If this is 0, both J and K are equal to 0. And if this is 1, both J and K are equal to 1. This would represent the state where we have no change. And this will represent the state where we have output complemented. This means that if we had a 0, 1 at the output, we'll have a 1, 0 at the output. Or if we have a 1, 0 at the output, after toggling, we'll have 0, 1 at the output. Any questions till now?
सर ये कॉम्प्लीमेंट वाली दोबारा समझा दो.
If we have this circuit that's in front of you at the left side, if you look closely, J and K are equal to the same input, T. J and K cannot go in a opposite manner, like you cannot have j equal to 0 and k equal to 1 over here. Can you have that? Can you have that state where j is equal to 0 and k equal to 1 in this type of circuit that's in front of
No,
you?
sir.
No, sir.
Or can you have a state where j is equal to 1 and k is equal to 0?
No, sir.
So this means that we are only left with two states, which is either the 0, 0 state or the 1, 1 state. And both of these states are controlled by a single switch, that is T. If T is 0, both j and k are 0, 0. If T is 1, both j and k are 1, 1. Which simply means that if T is 0, there would be no change. And if T is 1, the output would be complemented. Now you have to tell me what happens over here in this circuit. It's basically the same one. It's working in the same way, but we have a different scenario over here, a different circuit diagram over here. The T flip-flop was being made from the JK flip-flop over here. And in this case over here, it's being made from the D flip-flop over here. Meanwhile, Rafe, please check if you have the right screenshots of the current participants. If somebody has entered just now, you should have his or her name as well. Okay, so if T is 0 and Q bar had the state, if I say 1 and 0, what would happen at the output? Which gate is this? First of all,
XOR.
okay. So 1 would travel over here.
One output be one aega, odd number of ones.
Okay, okay. So it will retain the memory.
Yes, sir.
So T0 and the output would be no change in this case. What if
Yes, sir.
this was not equal to 1, this was equal to 0, and this was equal to 1? A 0, 0
Yes, sir.
would be the output.
0. Still
So,
no change.
so this tells us that if we have toggle switch equal to 0, the output is going to retain itself. Am I right?
Yes, sir.
Okay. Now let's change the situation with the toggle switch 1. If there was 1 over here, 1 would have been would have appeared over here. What would have been the
Complement.
output now?
Complement.
Yes. Now the 0 would have changed to 1 and the 1 would have changed to 0.
0.
Is this clear?
Yes, sir.
Now let's suppose that we have D equal to 1. 1 would have traveled over here. What would have been the output of this XOR gate?
0.
0. And now the output 1 and the 0 would toggle and the output would become equal to 0 and 1. So we are able to make the toggle flip-flop, the T flip-flop from the D flip-flop.
सर
Yes.
सर मुझे इस चीज की समझ नहीं लग रही, क्लॉक की वैल्यू कैसे चेंज हो रही है?
Which value?
क्लॉक मतलब कि डी फ्लिप फ्लॉप में हमने जो क्लॉक की वैल्यू चेंज कर रहे हैं जैसे 0 1, इससे थोड़ा कंफ्यूज हो रहा हूँ यहाँ पे.
Okay, that's a nice question. We are only assuming the outputs are changing because we are having a positive edge. The outputs would not change until and unless we have a positive edge over here or over here. Or if there was a not over here, the outputs would not have changed until and unless we have a negative edge over here and over here as well. So all of these outputs, whether they are from the JK flip-flop, from the T flip-flop from the JK flip-flop, or the T flip-flop from the D flip-flop, the output would only and only change if and only if we have a positive edge for the positive edge triggered D flip-flop, or the negative edge for the negative edge triggered D flip-flop. The output would not change if there is no positive or negative edge for the recommended D flip-flop, and our whole effort for changing the output would go in vain. There would be no effect at the output if we do not have the required positive or the negative edge.
Oh, ठीक होगा.
While teaching this all, I assumed that the output would change because we are having a positive edge over here and here as well. If there was no positive edge appearing over here or here, the output have no change. Okay.
Yes, sir. Okay. Thank you.
Okay, so I guess that's quite enough for today.